Imagine a world where machines can learn and adapt as efficiently as humans. We're not quite there yet, but why? What hurdles do we face in the journey to achieving this vision? Machine learning, the concept that underpins artificial intelligence, is the key to unlocking this future. Its potential is vast, from self-driving cars to virtual assistants, from predicting weather patterns to diagnosing diseases. Yet, even in 2024, we haven't fully realized this potential. Why is that, you ask? Well, let's break it down. We face challenges in securing high-quality, unbiased data in sufficient quantities. We grapple with making our machine learning models interpretable, so we can understand how they're making decisions. We're also confronted with the task of scaling these models as data grows in size and complexity. Add to this the need to ensure security and privacy, and the ethical considerations of AI's growing role in our lives. In this video, we explore 5 major challenges that machine learning has yet to overcome. Machine learning models are only as good as the data they're trained on, but finding high-quality, unbiased data in sufficient amounts is easier said than done. The truth is, we often grapple with data that's riddled with imperfections. It's like trying to bake a gourmet cake with subpar ingredients. The end result is likely to disappoint. Moreover, the specter of data bias looms large. It's like a pesky fly at a picnic, threatening to spoil the fun. Data bias can lead to models that give unfair or inaccurate outcomes, skewing the lens through which we view the world. So, what's the antidote to these data dilemmas? Well, there's no magic bullet, unfortunately. However, improved data collection methods and techniques to reduce bias can go a long way. Think of it as swapping out those subpar ingredients for gourmet ones, or shooing that pesky fly away. Solving the data problem is a key step towards improving the accuracy and fairness of machine learning models. Ever wondered how a machine learning model makes its decisions? Well, you're not alone. The lack of transparency in these models is a major challenge. You see, these AI systems often operate as black boxes. They take in data, churn out predictions, but the process in between, it's often a mystery even to their creators. This is what we call model interpretability, or rather, the lack thereof. Why is this a problem? Well, imagine using a model to predict something critical like medical diagnoses or loan approvals. If we can't understand how the model made its decisions, how can we trust its predictions? Here's the good news. Researchers are developing methods to make AI more explainable. These techniques aim to shed light on the inner workings of models, so we can better understand and trust the results. Transparency is key to building trust in machine learning models, especially when they're used in critical applications. As datasets get bigger and more complex, so do the challenges of scalability and security. Picture this. You're hosting a party and suddenly, instead of 10 guests, you have 1,000. The sheer volume can be overwhelming. That's scalability in the world of machine learning. Larger datasets mean more information to process, and traditional systems can struggle to keep up. Researchers are developing new techniques, like distributed computing, to handle this data deluge with grace. Now imagine your party guests rifling through your private documents. Not a pleasant thought, right? That's the security issue. Machine learning models often deal with sensitive data, and ensuring its security is paramount. It's like having a top-notch security system for your home, where the home is your data. Enhanced security measures are being developed to protect this data from prying eyes. Addressing scalability and security issues is crucial for the wide-scale adoption of machine learning. The rise of machine learning brings with it a host of ethical questions. As this technology becomes more ubiquitous, we're forced to grapple with issues of fairness and discrimination. How can we ensure that these systems don't perpetuate existing biases or create new ones? It's a complex problem, and one that requires constant vigilance and a commitment to ethical data practices. Then there's the matter of job displacement. As machine learning automates more tasks, some professions may become obsolete. This could lead to significant societal shifts, and it's important that we're prepared to support those affected. So, what's the solution? Well, there's no one-size-fits-all answer. But developing ethical guidelines and regulations is a good start. These can help ensure that machine learning is used responsibly, and that its benefits are distributed fairly. As we continue to advance in the field of machine learning, it's vital that we consider the ethical implications and strive to use this technology responsibly.